8. Appendices in BS 7671. The appendices in BS 7671 provide supplementary information, guidance, and reference data to support the application of the regulations. While not part of the core regulations, they are essential for a deeper understanding and proper implementation of BS 7671. Appendix 1. British standards referenced in BS 7671. Purpose. Appendix 1 serves as a comprehensive reference for the British standards, BS, and harmonized documents, HD, mentioned within BS 7671. It provides essential links between BS 7671 and the broader framework of standards that underpin safe and effective electrical installations. Contents. List of standards. Includes all the British standards referenced throughout BS 7671. For each standard, it provides the standard number, title, and the relevant sections in BS 7671 where it is cited. Purpose of standards. Helps users identify specific standards relevant to different aspects of electrical installations. Acts as a guide for further in-depth study or compliance verification. Applications. Useful for engineers, designers, and electricians who need to ensure compliance with reference standards. Encourages uniformity in the interpretation and application of installation practices. Keynotes. Appendix 1 is normative, meaning it is part of the core requirements for compliance with BS 7671. It ensures installations meet not only BS 7671, but also related standards that contribute to safety and functionality. This appendix acts as a vital tool for professionals to navigate and apply the standards effectively, ensuring that installations align with both BS 7671 and the wider regulatory landscape. Appendix 2. Statutory regulations and associated memoranda. Purpose. This appendix highlights the statutory regulations and memoranda applicable to electrical installations in the UK. It provides guidance on how BS 7671 can be used to demonstrate compliance with these regulations. While BS 7671 itself is non-statutory, it is recognized as evidence of compliance with legal requirements. Contents. Key statutory regulations. Electricity safety, quality, and continuity regulations. ESQCR covers electricity distribution, prohibiting certain systems like pin conductors or TNCS for external metallic structures. Building regulations. Ensures safety and compliance in construction and electrical work. Electricity at work regulations. EWR focuses on safety in electrical work, outlining responsibilities and best practices for protection. Associated memoranda. Provides supplementary guidance to help interpret statutory regulations. Examples include health and safety memoranda relevant to the electrical industry. Enforcement authorities. Identifies organizations responsible for ensuring adherence to the regulations, such as Health and Safety Executive, HSE, and building control bodies. Keynotes. The regulations are legally enforceable and can be used in court as evidence of compliance or non-compliance. BS 7671 serves as a recognized method for meeting statutory requirements, ensuring that electrical installations are designed and maintained to high safety standards. This appendix is crucial for understanding the legal framework within which electrical installations must operate. Appendix 3 Current characteristics of overcurrent protective devices. Purpose. Appendix 3 provides critical information about the behavior of overcurrent protective devices, such as fuses, circuit breakers, and RCDs, when subjected to various levels of current over time. This ensures appropriate device selection to protect circuits from damage or danger in fault conditions. Contents. Time/current characteristic curves. Illustrates the relationship between fault current magnitude and the time taken by the protective device to disconnect. Includes curves for different device types like Type B, Type C, and Type D circuit breakers. Enables engineers to ensure timely disconnection for overload or fault conditions. Earth fault loop impedance. Discusses how impedance measurements ensure protective devices operate within specified time frames. Helps verify the suitability of devices under real-world conditions. Residual current devices, RCDs. provides disconnection time data at 1x and 5x the rated residual current. Emphasizes the importance of a 150 milliseconds disconnection time to protect against electric shock. Tables for device behavior. Summarizes key data points from time/current curves in an easy-to-use tabular format. Includes factors like disconnection time limits for protective devices. Keynotes. 0.8 factor. Adjusts impedance values to account for practical variances in installations. Enables precise device selection and compliance with disconnection time regulations to ensure safety. By understanding and applying the information in Appendix 3, electrical professionals can design and implement systems that effectively handle overcurrent scenarios while safeguarding people and equipment. Appendix 4. Current carrying capacity and voltage drop for cables. Purpose. This appendix provides essential data for selecting and designing cables in electrical installations. It ensures cables are appropriately sized to carry the design current without overheating, and that voltage drops remain within acceptable limits. Contents. Current carrying capacity. Tables for various cable types, e.g., armored, non-armored, copper and aluminum. Installation methods and their impact on heat dissipation. Correction factors for ambient temperatures, grouping of cables, soil thermal resistivity, and depth of burial. Voltage drop. Tables showing voltage drop per ampere per meter for different cable types and sizes. Formulae for calculating voltage drop in circuits. Maximum allowable voltage drop percentages, e.g. 3% for lighting, 5% for other uses in public supplies. Reference methods. Illustrated and described methods for cable installations, e.g. buried, clipped to surfaces. Impact on cable selection and heat dissipation. Keynotes. Reference tables like 4B1, ambient air temperature correction factors, for C1 grouping correction factors, and other simplify adjustments during cable selection. Practical guidance for ensuring compliance with regulations about overload protection and voltage drops in circuits. This appendix is invaluable for electrical professionals, providing all the necessary data to ensure safe and efficient cable installations. Appendix 5. Classification of external influences. Purpose. Appendix 5 focuses on external influences that can affect electrical installations. It classifies these influences into categories based on environmental conditions, usage factors, and building construction characteristics. Understanding these factors ensures that electrical equipment is appropriately selected and installed to suit the surrounding environment. Contents. Categories of external influences. Category A. Environment addresses environmental conditions like temperature, humidity, and vibration. Category B. Utilization considers how the installation is used, including user interaction and frequency of use. Category C. Construction focuses on characteristics of the building, such as materials and structural design. Detailed classification. Each category is further divided into specific influences, represented by combinations of letters and numbers, e.g., AA for temperature, AB for water exposure. Provides examples of typical scenarios and necessary precautions. Application. Helps in selecting equipment that meets the requirements of specific external conditions. Guides designers and electricians in assessing risks and ensuring safety in various environments. Keynotes. This appendix is particularly useful for installations in challenging environments, such as industrial sites, outdoor areas, or specialized buildings. Considering external influences during the design phase is critical for the long-term safety and reliability of installations. Appendix 6. Model forms for certification and reporting. Purpose. Appendix 6 provides standardized model forms to record essential information for electrical certification and reporting. These forms are designed to ensure compliance with BS 7671 and help maintain consistency in documentation. Contents. Types of forms. Electrical Installation Certificate, EIC used for new installations to certify compliance with BS 7671. Minor Electrical Installation Work Certificate, MEIW used for minor alterations or additions to an existing installation. Electrical Installation Condition Report, EICR, used to evaluate the safety and condition of an existing installation. Form layouts. Includes templates with required fields such as details of the installation, test results, and responsible persons, e.g., designers, installers, inspectors. Standardized format ensures all relevant information is documented clearly and consistently. Schedule of test results. Provides detailed fields to record the results of essential electrical tests, e.g., insulation resistance, earth loop impedance. Ensures proper testing and verification of the safety and functionality of the installation. Coding system for ICR. Describes the use of codes like C1, immediate danger, C2, potential danger, and C3, recommended improvement, for reporting observations. Keynotes. The appendix also includes updated requirements, such as functional checks for AFDDs, arc fault detection devices. Accurate use of these forms is crucial for demonstrating compliance and ensuring the safety of electrical installations. This appendix is a practical tool for professionals to document and certify their work, ensuring adherence to BS 7671 standards. Appendix 7, Harmonized Cable Core Colors. Purpose. Previously, Appendix 7 provided information on harmonized cable core colors used in electrical installations. These colors were standardized across Europe to ensure consistency and improve safety when working with electrical systems. Contents. Detailed the changes from old UK cable core color codes to the harmonized colors. Highlighted color codes for single-phase and three-phase systems, including neutral and earth conductors. Explained the rationale for harmonization, aiming to reduce errors and enhance compatibility across countries. Current status. Deleted in BS 7671:2022. The content previously found in Appendix 7 has been removed. Relevant information may now be located in other sections of BS 7671 or referenced from external standards. Appendix 8. Current carrying capacity and voltage drop for busbar trunking and power track systems. Purpose. Appendix 8 focuses on the current carrying capacity and voltage drop for busbar trunking and power track systems. It provides guidelines and data to ensure these systems are designed and installed safely and efficiently. Contents. Current carrying capacity. Data on the capacity of busbar trunking and power track systems to carry current without overheating. Takes into account factors such as conductor material, size, and installation methods. Voltage drop. Guidance on calculating voltage drop over the length of the system. Includes formulae and data tables for various configurations and conditions.
Installation considération.
Highlights specific requirements for the design and installation of busbar trunking and power track systems. Addresses key factors like ambient temperature, length of the system, and load types. Mathematical calculations. Provides methods for determining current carrying capacity and voltage drop under different scenarios. Encourages proper documentation and adherence to the outlined standards. Keynotes. Essential for professionals working with these systems to ensure compliance with safety and performance requirements. Information must be tailored to the specific power track system being used. Appendix 8 is especially useful in settings where busbar trunking and power track systems are employed for distributing power efficiently, such as industrial and commercial buildings. Appendix 9 definitions multiple source DC and other systems. Purpose. Appendix 9 provides definitions and explanations for electrical systems with multiple sources, direct current, DC, configurations, and other specialized arrangements. It serves as a reference for understanding these systems and their unique requirements. Contents. Multiple source systems. Defines systems with more than one electrical supply source, e.g., grid supply and generators. Explains considerations for safe integration, such as synchronizing supplies and isolating faults. DC systems. Covers definitions related to direct current systems, including voltage levels, polarity, and applications. Highlights the use of DC systems in renewable energy, e.g., solar panels, and transportation, e.g., electric vehicles. Other systems. Addresses unique configurations or systems that don't fall under conventional AC or single-source setups. Provides terms and explanations to clarify the application of BS 7671 regulations in these contexts. Keynotes. This appendix is particularly useful for professionals working with modern electrical systems that involve renewable energy or complex configurations. Clear definitions ensure consistent interpretation and application of safety standards. Appendix 10, Protection of conductors in parallel against overcurrent. Purpose. Appendix 10 provides guidance on the protection of conductors that are installed in parallel, ensuring they are safeguarded against overcurrent conditions. This is particularly relevant in systems where multiple conductors are used to distribute electrical load. Contents.
Conductor arrangement.
Discusses scenarios where conductors are connected in parallel to share the electrical load. Highlights the need for uniform current distribution across parallel conductors. Overcurrent protection. Explains methods for protecting parallel conductors against overcurrent. Ensures conductors are adequately protected by devices like fuses or circuit breakers. Addresses challenges such as uneven current distribution due to differences in impedance or conductor length. Factors influencing parallel conductors. Covers factors like conductor material, cross-sectional area, and installation methods that affect current distribution and protection. Includes precautions to prevent overheating and ensure compliance with regulations. Keynotes. Proper design and protection of parallel conductors are essential to avoid issues like overheating, equipment damage, or unsafe conditions. Selection of protection devices must align with the characteristics and requirements of the conductors. Appendix 10 is critical for systems using parallel conductors to distribute electrical load efficiently and safely. Appendix 11, Warning and User Instruction Labels. Purpose. Appendix 11 provides guidance on the use of warning and user instruction labels in electrical installations. These labels are crucial for ensuring safety by clearly communicating essential information to users and personnel. Contents. Types of labels. Labels indicating safety-related instructions such as safety electrical connection do not remove, required at points of earthing conductor connection to earth electrodes, and bonding conductors to extraneous conductive parts. Other mandatory warnings. Apply to locations like main earthing terminals, separate from switchgear. Placement of labels. Specifies where each type of label should be installed to ensure visibility and compliance with safety regulations. Material and visibility. Stresses the use of durable materials for labels to withstand environmental influences. Ensures legibility and adherence to safety standards. Informative warnings. Labels may also include additional instructions to guide users, such as operational warnings or restrictions. Keynotes. Proper labeling is essential for maintaining safety and reducing the risk of accidental disconnection or misuse. These labels play a vital role in communicating critical information, especially in installations with complex configurations. Appendix 12, Voltage drop in consumers' installations. Status. Appendix 12 has been removed from BS 7671:2018, 18th edition, and its content has been moved to Appendix 4. The information previously in Appendix 12 pertained to voltage drop allowances in consumers' installations. It provided guidance on calculating voltage drops to ensure they remained within acceptable limits for the safety and efficiency of electrical installations. Key points now covered in Appendix 4. Voltage drop limits. 3% for lighting circuits. 5% for other circuits. Equivalent to 6.9 V and 11.5 V in a 230 V system for lighting and other circuits, respectively. Calculation of voltage drop. Tables and formulae provided for calculating voltage drops based on circuit length, load, and cable properties. Ensures installations comply with design standards for efficient power delivery. Practical application. Voltage drop considerations are critical when selecting cable sizes and designing circuits, particularly for long runs or heavy loads. Appendix 13. Escape routes and fire protection. Purpose. Appendix 13 provides guidance on the installation of electrical equipment in protected escape routes and fire protection systems. It ensures that electrical installations do not compromise the safety of escape routes during emergencies. Contents: protected escape routes. Electrical equipment in protected escape routes should be limited to essential systems, such as emergency lighting, fire detection and alarm systems, other critical safety systems. Non-essential equipment should not be installed in these areas to avoid obstructing evacuation or increasing fire risks. Fire-resistant cables. Cables used in escape routes must meet specific fire resistance standards, such as resistance to flame propagation. Ensures that cables maintain functionality during a fire, supporting critical safety systems. Cable management systems. Specifies requirements for cable management systems, such as conduits, trunking, and cable trays, to ensure they are non-flame propagating. Highlights the importance of using materials that comply with fire safety standards. Keynotes. The appendix emphasizes the importance of maintaining clear and safe escape routes in buildings. Proper selection and installation of electrical equipment and cables are critical to ensuring safety during emergencies. Appendix 14, Determination of Prospective Fault Current. Purpose. Appendix 14 provides guidance on determining the prospective fault current, PFC, in electrical installations. This is crucial for ensuring that protective devices are appropriately rated to handle fault conditions without causing damage or posing safety risks. Contents. Definition of PFC. PFC refers to the highest current that can flow during a fault condition, such as a short circuit or earth fault. Accurate determination of PFC is essential for selecting protective devices like circuit breakers and fuses. Methods for determination. Provides methods for calculating or measuring PFC at various points in an installation. Includes considerations for different system types, such as TN, TT, and IT systems. Testing requirements. Emphasizes the importance of testing to verify PFC values during installation and periodic inspections. Highlights the use of appropriate test equipment and procedures. Application and design. Ensures that protective devices are rated to interrupt fault currents safely. Helps in designing installations that comply with BS 7671 regulations. Keynotes. Determining PFC is a critical step in ensuring the safety and reliability of electrical installations. Proper documentation of PFC values is necessary for compliance and future reference. Appendix 15, Ring and Radial Final Circuit Arrangements. Purpose. Appendix 15 provides guidance on the design and implementation of ring and radial final circuits, ensuring compliance with Regulation 433.1. It helps professionals understand the differences between these circuit types and their appropriate applications. Contents. Ring circuits. Describes the arrangement of ring circuits, where conductors form a loop starting and ending at the distribution board. Highlights the benefits, such as reduced voltage drop and efficient current distribution. Provides guidance on the maximum floor area a ring circuit can serve, e.g., 100 square meters for a standard ring circuit. Radial circuits. Explains the layout of radial circuits, where conductors run directly from the distribution board to the final outlet. Discusses the use of radial circuits for specific loads, such as cookers or immersion heaters. Provides recommendations for cable sizes and protective devices based on the circuit's load. Spurs. Covers the use of spurs, additional outlets connected to the main circuit. Differentiates between fused and unfused spurs and their limitations. Advises on best practices to minimize the number of spurs for better circuit design. Design considerations. Emphasizes the importance of balancing loads across the circuit to prevent overloading. Provides examples of typical applications for ring and radial circuits in domestic and commercial settings. Keynotes. Ring circuits are commonly used in domestic installations for general-purpose socket outlets. Radial circuits are often preferred for dedicated loads or in smaller installations. Proper design and implementation of these circuits are essential for safety and efficiency. Appendix 16, Devices for Protection Against Overvoltage. Purpose. Appendix 16 provides guidance on the use of devices designed to protect electrical installations and equipment from overvoltage conditions. These devices, known as surge protection devices (SPDs), are essential for safeguarding against transient overvoltages caused by lightning strikes, switching operations, or other disturbances. Contents: types of SPDs. Type 1 SPDs, designed to protect against direct lightning strikes, installed at the origin of the installation. Type 2 SPDs, protect against transient overvoltages from indirect lightning strikes or switching operations, installed at distribution boards. Type 3 SPDs, provide localized protection for sensitive equipment, installed close to the equipment. Installation guidelines. SPDs should be installed as close as possible to the point of entry for external conductors, e.g., at the main distribution board. Proper coordination between different types of SPDs is necessary to ensure effective protection. Connection methods. Illustrations and examples of SPD connections in various systems, such as TT, TN, and IT systems. Emphasizes the importance of minimizing connection lead lengths to reduce impedance. Testing and maintenance. Recommends periodic testing of SPDs to ensure functionality. Highlights the need for replacement if SPDs show signs of wear or damage. Keynotes. SPDs are critical for protecting sensitive electronic equipment and ensuring the safety and reliability of electrical installations. Proper selection and installation of SPDs can significantly reduce the risk of damage from overvoltage events. Appendix 17 Energy Efficiency Considerations. Purpose. Appendix 17 focuses on energy efficiency in electrical installations, providing guidance on designing systems that minimize energy consumption while maintaining safety and functionality. Contents. Energy efficiency principles. Encourages the use of energy-efficient equipment and practices, such as LED lighting and high-efficiency motors. Promotes the integration of renewable energy sources, like solar panels, into electrical systems. Load management. Highlights the importance of managing electrical loads to reduce energy waste. Recommends the use of smart systems to monitor and control energy usage. System design. Provides guidance on designing electrical systems with energy efficiency in mind, including proper cable sizing and minimizing losses. Encourages the use of energy-efficient technologies, such as variable speed drives and energy storage systems. Environmental impact. Emphasizes the role of energy-efficient installations in reducing carbon emissions and environmental impact. Aligns with global efforts to promote sustainability in electrical engineering. Keynotes. While energy efficiency is not a core requirement of BS 7671, it is increasingly recognized as an important consideration in modern electrical installations. Appendix 17 serves as a valuable resource for professionals aiming to balance energy efficiency with compliance and safety.